Okay, we're going to return to the borehole design, and we're going to look at a few of the uh, other configurations besides single YouTube. And I'm not sure how useful this will be, and I don't really have much in the way of a planned agenda. Let's calculate the borehole thermal resistance. Right, we were on double YouTube or single YouTube before. If we look at double YouTube, STR11, again, we'll go with 3/4 inch pipe. And the B spacing, which is not exactly the same definition, but it's similar idea. Okay, so we've got those set. We've got the same grout conductivity and same short circuiting effects, which have make no difference for these short boreholes. Our borehole resistance is 0.5975, so that's actually gotten higher. Well, yeah. Okay, sorry, I see what I did. I had made a quick change to the borehole diameter and had apparently made it into 45.5, which is not very good. We need to reset the spacing though. There we go. Okay, so calculate the borehole resistance. It's 0.3228. So if you remember with the single YouTube and 0.4, I think it was 0.4553. We can again check the effect on the size. All right, 407 feet. So it's less than the single YouTube, right? And well, it was 441 to 407, so maybe, I don't know, 7 or 8%, something like that. If we now go back and use thermally enhanced grout, we should see some further increase. By the way, the Reynolds number is lower because we now have two pipes that are in parallel with each other, and so we don't have quite as high a convection coefficient. But if we calculate the borehole resistance with the higher grout conductivity, now we got 0.1806. That's pretty good. I think even putting the C spacing in with the really high grout conductivity, I think we only got down to 0.17 in the previous example. So you can see, right, 355 feet. So if you remember when we had the single YouTube, we went all the way up to a grout conductivity of 1.6 and used this C spacing with spacers. We pushed them against the wall. Right, we only got down to 337.8 feet. So we're actually getting almost all the benefit with just a more standard enhanced grout. So on with the double YouTube. Okay, so let's go back. Let's look at the concentric YouTube. These are, sorry, it's not a YouTube, it's just a concentric tube. So we have it's a little bit confusing diagram. We have a borehole diameter, we have an outer pipe, and then an inner pipe. Right, and these diameters are all related to the outer pipe and the inner pipe inside and outside diameters. So, for example, we can set the outer pipe diameter. We can choose 4 inches. I think this is not going to be a good idea. You'll see in a minute why. Let's just choose 1 inch pipe inside. Well, let's leave it 3/4 inch side. So if we calculate the borehole resistance, right, we've got basically a 1/2 inch on either side of grout around the outside of the outer tube. We have a fairly large outer tube, so we're going to have a fairly low Reynolds number in the annulus. Okay, so you see the borehole resistance is 0.2098. Well, actually, that's better than I thought it was going to be. If you look down here, you'll see the convection coefficients are set at the inside of the inner part 464 and at the outside of the inner pipe 34, 0.265. Right, and it's the one at the outside of the inner pipe that's controlling it. It's got a fairly high resistance. All right, so we could try changing the outer pipe to make it smaller. Let's see if we say 2 inches. Yeah. So now we're going to have a much smaller annulus between the two pipes, but we have a larger grout region. Just let's do that and see what it does to both the resistance and the convection coefficients. Okay, so now we've got a larger convection coefficient at the outside of the inner pipe, which is what we were hoping for. Unfortunately, I think what we've done is we now have a much thicker layer of grout outside, which is probably hurting us. So let's go to a smaller borehole diameter. It's probably what we need if we're going to use a coaxial pipe. The outer diameter of our outer pipe is 2.4 inches. So let's see if we could go down to 3 inches. Now we're going to need to change. No, that's okay. 3. Yeah, this should all be fine. Okay, 0.1992. Okay, that's approaching the double U-tube. It's, yeah, that's pretty good. Why don't we size that and see? $396. So it's somewhere in the middle range of what we looked at already. There's likely more room for optimizing this. You know, a lot of it depends on how hard it is to get down into a narrow borehole. You know, and then there may be room for optimization in terms of the relative ratio of the outside pipe and the inside pipe. All those things can be done, but yeah, I don't actually have a lot of experience with these, and I don't think they're commonly used here in North America. They've become more popular in places like Sweden, where they use really deep boreholes. There have been a few PhD theses on these, and so on. But anyways, that's concentric. We're not going to look at standing column well. Standing column well is not just another borehole design. First of all, it's like a water well, and the water inside the tube is open to the rock. And it has some very complicated or more complex features related to bleed rate, whether you want to pump some water off either intentionally, or if you're also using your well as a water well and you're literally drawing domestic water off, right? It's going to bring water in from the surroundings, and that's going to change it's going to change a number of things. So I think I'll leave that for possibly another future lecture, but that's just a little bit on the, oops, yes, we're not going to do that. Go back to our YouTube. And we'll stop there. Thanks.